this particular test standards was developed by the semiconductor industry for a number of years. So it came out early on 2000 and has been updated several times ever since. It's widely adopted and used, critical for manufacturers of semiconductor equipment, very costly if there are any losses in the production. So they want to make sure their equipment will ride through very severe line anomalies, and that's what this standard is designed to check. And it can do so with a number of different levels, test levels and durations that you see here on the right. Some examples of some of the durations. See there, they can be pretty long, up to a second at 80%, and up to 200 milliseconds at 50%. That's about 3 to 4 cycles. So that's definitely pretty long for a voltage dip to 50%. And a lot of equipment, normal equipment, would probably have a hiccup or some issues with it. This type of equipment must be designed to do this, must be able to ride through this. And that generally means more hold-up capacitance in the input stages than you would normally use in equipment like this. So there are ways to make this work by designing it for it, and then you still, even if you do that, you still have to validate, verify, and test. This is often done by test labs that can run these tests for you, and a lot of developers of this equipment will want to do their own pre-tests in-house before they go to a TUV or a test lab like NEMCO, because they're expensive to go there, and they charge you by the hour, and it can take a lot of time if you fail during a test, and you have to go back later. So a lot of manufacturers of this equipment will try to do their testing in-house, and that's what would require a programmable AC source or grid simulator to do this. So to have these programmable sequences, you can obviously program it manually, but with the test sequence, it obviously is much easier to do. It's already pre-written, and of course, it also generates a test report at the end. So all these dips and interrupts can be selected from the test sequence and executed once or multiple times repeatedly as needed to validate and verify your equipment has the proper write-through capabilities. So the source for this has to be able to do all these levels, of course. As I mentioned, the rise and fall time is not quite as onerous as for the IC voltage dips and interrupts. It's going to be less than 100 microseconds. Our equipment will all meet that without any issues. So it's not a problem for the Pacific Power Source rise and fall time on our AC sources. Voltage levels, of course, are well within our ranges as well, because they're typical grid voltages. Stability, less than 0.5% voltage load regulation is again well within our capability as well. And of course, you have to have sufficient power levels, and that can be high on some of this equipment. You're talking about fairly large equipment that has high power levels, so you're probably looking at parallel AFX or AZX type equipment to be able to do this. The test sequences make this obviously very user-friendly. You don't have to write your own test sequences, although you could if you wanted, but this is all done for you and saves you quite a bit of time in terms of developing your tests and executing them. So runs in the browser window, the browser interface, so you have the advantages of the browser functions, both LAN or USB, and if you want, you don't need to write your own test software like some users did in the past. So it can be operated, from the unit anywhere near or remote as needed, and you can monitor it from a distance as well if you want. So the test sequences are, as you know, our operating user interface is generally the same. You have configuration setting at the beginning, so the user is guided through the various stages. You select your nominal settings, for your up to 30, 50 hertz, and your phase mode and phase, A is usually your reference. Start phase angles for your dips, and then the sag levels you see there, 3 different levels you can set as part of one test sequence. So sequence runs on its own. At the end, it generates a report, and you can send that report to a printer or PDF file and use it for documentation for your compliance documentation. So very useful sequence. This is an example of the sags running, and you can see the steps on the bottom right. So if you want to see what's happening, it'll show you the sequence that it goes through, the durations. This is the capture of the internal scope of one of those dips. This looks like a 70% dip by the looks of it. And the duration is shown with the cursors there. So you can see that it lasted for the amount of time that's required. So at the end, again, you can determine, obviously by observation, if there was any hiccup on the equipment. It's not something the power source can really determine. It's just providing the voltage anomalies. So the user has to monitor and observe the equipment for normal operation. And if so, you can select a pass result, which will be incorporated in the report. So at the end, you get, here's a sample of the report, shows you all this applied anomalies, voltage dips and interruptions applied during the EUT. EUT information is included that you can provide on the prompt. And at the end, the user determined results is included as well, as far as pass or fail. So makes testing for semi, a lot more convenient and saves you time. And when you go to an actual third-party lab for certification, you can, be more confident that your equipment will pass, and you won't have to spend additional time and money rerunning a test at a test lab. So by having the ability to do it in-house, we do something similar, although we don't have to comply with semi 47. Of course, our equipment is not typically used for semiconductor manufacturing, but we have similar requirements for CE mark and UL compliance that we test in-house. The engineering will do their own pre-testing in-house before they venture out to a third-party lab and start paying the daily rates to run the tests there for third-party certification. So very common practice for most customers to do that in the interest of saving time and money.